Hello, this is the fifth video on electricity and magnetism and can be used by students from class 6 to class 10. In the previous video, we saw that water conducts electricity when salt or some kind of acid is added to it. So it allows an electric current to pass through it, and we used a simple circuit like this. And when the current passed through water, the LED bulb, the LED light glowed. So that is how we could conclude that water conducts electricity. In this video, we are going to see what happens if we pass a larger amount of current through water. So this process is called as electrolysis of water. What happens if we pass a sufficiently large amount of electricity through water? So we are going to use a similar circuit. So we need more electricity. So we may use more than one electric cell. So you can use a 9 volts cell, or one or more, two of them would be enough. So these are the connections. So from the positive cell, positive terminal of the cell, there is one wire, a terminal or a plate. And from the negative terminal also, there is a wire coming. It could be a plate or a wire. So these metal plates, rods that lead or which lead the current into water called as electrodes. So they can be made of various metals, copper, silver, zinc, aluminium. We are going to use aluminium. So the electrode connected to the positive terminal of the battery is called anode, and electrode connected to negative terminal is called the cathode. We will know the reasons for these names later when we study about electrons, their charge, and so on. And when the electricity passes through the liquid, the conducting liquid is called as electrolyte. So it is going to be water with a few drops of dilute sulfuric acid added to it. This is going to be our setup. I have a plastic can filled with water. I have made holes at the bottom of the can, and I have pushed two thick aluminium wires through it. And I have made them leak-proof by using quick fix. So this is the water to which I will add a few drops of acid. So these wires coming out at the bottom are the electrodes. And I have to pass current through them. So I am going to use this battery eliminator, which is instead of the cell. So if you do this, you have to only use a 9 volts cell bought from the market. But I will use this battery eliminator, which is simply an electric cell. The red terminal is the positive and the black is the negative. So I'm going to connect the wires using crocodile clips. The battery is now switched off. There is no current passing. So the crocodile clips do not touch. Now I have switched on the current. And I'm using 8 volts of voltage. So now you can see as soon as the current passes through between the electrodes, you can see some bubbles of gas forming in the water. So on the left electrode, which is the the cathode connected to the negative. Uh, it's connected to the negative terminal. So you can see bubbles forming vigorously and moving up. So there's a chemical reaction happening in water when you pass current through it. So there are bubbles forming on the other electrode also, but not as profusely as those forming on the cathode. So you can see that there are bubbles forming on the anode also. So gas is being released from water when you pass electricity through it. So water splits into two gases. In a chemistry video later, we will learn that water is a compound made of two elements, hydrogen and oxygen. Okay. And when you pass a current through water, water splits into hydrogen and oxygen. So this is called as electrolysis of water. So this hydrogen gas, which is formed close to the cathode, uh, is the one that we see there, the bubbles which are moving up. They can be collected by what is known as the downward displacement of water. So we're going to collect this gas and test it. Hydrogen is an inflammable gas, so it burns when lit. So how do we collect this gas? We're going to fill a test tube with water and invert it over the cathode. So we know that from air pressure, if you fill a test tube, close the mouth and invert it in a basin of water, and then release the mouth of the test tube, the water in the test tube stays up. It does not flow out because air pressure is keeping it up. Okay, so the test tube filled with water, which is inverted on the cathode, contains water, and the gas will enter the test tube and go up, and it will collect at the top of the test tube. So when the gas collects, a pressure builds, and that pressure will gradually push the water down. So water gets displaced down. So this time I'm going to collect the hydrogen gas which is forming on the near the cathode. So I'm going to take a test tube, fill it with water. So note that there is no current passing. It has the battery has been switched off. Okay, once the mouth is underwater, I let go, I release it, and then the water in the test tube stays up. So now I position the test tube on top of the cathode. So the gas that forms around it can enter it. Now I pass the current, and hydrogen gas forms. The bubbles go up into the test tube. They're collecting in the test tube. So as we wait, the top of the test tube gets filled with the gas. So this takes time. So you can see the separation of the gas and water, and the water becomes cloudy because of the gas bubbles. As time goes by, you can see the separation between gas and water clearly. So after about 8 to 10 minutes, half of the test tube is filled with the gas. So now I can use, I want to extract, I want to remove the test tube from water and test that gas. I'm going to test the gas to check that it is hydrogen by using a candle flame. So you can see the boundary between the gas and the water when I lift up the test tube. Now I switch it off. So no more current, no more hydrogen gas being generated. So we will trap whatever is, collect whatever has already been generated. So when I lift up the test tube, you can see that water. Okay, so I gently lifted it over the cathode. Now I close the mouth of the test tube once when it is still underwater, and then I invert it. So there's gas at the top and water below. So we have collected hydrogen gas. Now I'm going to check it. I bring a candle frame. So when I release the gas near the flame, so it has burnt with a pop sound, and then there was water vapor formed. So we collected hydrogen gas. We know it is hydrogen because of this one test that it it burned when exposed to flame. There was a pop sound, and some steam formed. Because when again hydrogen gas burns, it combines with oxygen and forms water again, which we see as steam. Hydrogen is an inflammable gas. So if we collect the gas which is forming at the other electrode, at the anode, then we can check that it is oxygen gas. So this way we have seen that when we pass an electric current through water, water splits into hydrogen and oxygen, which is a chemical reaction. When water forms, uh, when hydrogen burns and water forms, that's a chemical reaction. When water splits also, it is a chemical reaction. So electric current drives chemical reactions. This is the first of those chemical reactions driven by electricity. Later, we will see other reactions which are driven by electricity in a chemistry video. So this is the chemical effect of electric current. We stop here.